Hello student, welcome back. It is lecture 3, module 4, Microcontroller and Embedded System. Sangita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. Introduction to Embedded Systems. Lecture 3. Increasingly powerful integrated circuitry making an entire range of new applications possible. Complementary metal oxide semiconductor CMOS sensors, for example, have made the digital camera a component consumer item. These light sensitive chips positioned where film would normally be capture images and reusable digital files that our users can upload to their computer, manipulate with software and distributed electronically. Recent technological advances are enabling a new generation of smart cameras that represent a quantum leap in sophistication. While today's digital cameras capture images, smart cameras capture high-level description of the scene and analyze what they see. These devices could support a wide variety of applications, including human and detection, surveillance, motion analysis, and facial identification. Video processing has an insatiable demand for real-time application. Fortunately, Moore's law provides an increasing pool of available computing power to apply to real-time analysis. Smart cameras leverage very large-scale integrated VLSI to provide such analysis in a low-cost, low-power system with substantial memory. Moving well beyond pixel processing and compression, this system run a wide range of algorithms to extract meaning from streaming video because they push the design space in so many dimensions. Smart cameras are a leading edge application for embedded system research, detection and recognition algorithms. Although there are many approaches to real-time video analysis, we choose to focus initially on human gesture recognition, identifying whether a subject is walking, standing, waving, arm, or so on. Because much work remains to be done on this problem, we sought to design an embedded system that can incorporate future algorithms as well as use those we created exclusively for this application. So this is a human detection activity recognition algorithm. It has two parts: low-level processing algorithm identifying body parts and categorize their movements. B high-level processing algorithm use hidden Markov models and a gesture classifier to evaluate overall activity. So this is the model. It has recognition block, contour following block, ellipse fitting, graph matching. Here it is algorithm HMM for head. It is a mixture model. Another HMM for torso, HMM for hand, HMM for hand 2, then gesture classifier, then recognition activity. And the upper part, that is another video input is there, then image duplication, image modification, then video output, and from the graph matching, that is the output is going to this block. So this is the total activity. It is parted into two blocks, A part and B part. In the figure, algorithm shows low-level and high-level processing. The low-level component identifies different body parts and categorizes their movement in simple terms. And high-level component is application dependent. uses this information to recognize each part of the body and the overall activity of the person. Low-level processing. The system captures images from the video, then uncompressed or it may be compressed depending on MPG or JPG, and applies 4 different algorithms to detect and identify human body parts. So it is showing over there original image, B is the region of extraction, C is the contour following, D is the ellipse fitting. Region extraction. The first algorithm transforms the pixel of the image. It will be shown in figure 2 into matrix M into n bits, then eliminates the black background. It then detects the body part, skin area, depending on YUV color model, because there are different color models are there, RGB, HSB, YUV, and so on are there. Then the algorithm hierarchically segment the frame into skin tone and non-skin tone regions by extracting foreground adjacent to detect skin areas and combining these segments in a meaningful way. Then contour following. The next step in the process involves like linking the separate groups of pixels into contours that following geometrically define the region, and then filling the algorithm, the edge and component. Then ellipse fitting is there. Then finally graph matching will be there, and extracted ellipse will be fitted over there. And in the high level processing, it can be adapted to different application companies. The motion pattern of each body part described as a spatio-optimal temporal sequence of feature vectors in a set of frames to the pattern of known postures and gestures, and then uses several hidden markup models in parallel to evaluate the body's overall activity. We use discrete HMMs that can generate 8 different code words that check up, down, left, right circuit movement of each body parts. Motion detection and gesture recognition system. So this is the block diagram, functional block diagram. This is the image. Image is taking through lens, then autofocus, shutter driver and actuator, image driver and regulator, photometry interface and processing, audio acquisition part is also there. Then it will be audio processed through the microcontroller. This is the embedded part, total integrated embedded, but this is the core part. Microcontroller system timing memory interface, user interface, data IO interface. Then there is a battery system, power management, converter and control. Then DRAM is there. Then serial data IO, IRDA, RS-232, USB, IEEE 1394, audio out, storage media, flash memory, HDD, LCD controller and drivers, frame buffer, picture processing, image CO detector, then PAL or NTSC encoder, display. The digital still camera is a challenging application for image processing techniques. The basis of the algorithms applied to the data provided by the image sensor were first applied in camcorders. In fact, in the beginning, digital still cameras could be considered as a derivative of the camcorder technology modified to capture the still pictures. But 2 factors contributed significantly in the 2 systems, each human visual system, HVS characteristics, and the quality of analog cameras. It is well known that motion reduces the human visual system sensitivity to the high frequency contents, including artifacts of a picture. Consequently, the system is mainly intended to motion picture capture. The algorithm used can take advantage of that. Generally speaking, the complete system benefits from the reduced sensitivity of the HVS. Simpler algorithm translates into less hardware lower power consumption and lower cost. On the other hand, the image processing algorithm requires in digital still camera are very demanding as far as quality is concerned due to the HVS characteristics for stills and the quality already provided by analog or silver Hilda still cameras. Initially, digital cameras were strictly derived from camcorders. Consequently, the demand in quality for DSC greatly differentiated the two systems. Today, it is possible to say that camcorders benefit from the advances made to enhance the quality provided by DSC. For example, progressive sensors with bare CFA developed for DSC now are used in digital camcorders. So this is the DSC working principle. So this is the image array, the sensor part, color filter array, then the lens, then the illumination, then it is the scene, it is coming. So this sensor through lens, it is coming through the color filter, then imaging array is there. Then this is going to input processor, color engine is there, anti-vignette special distortion is there, then encoded, then to the, and this part is recovery engine. So this is a sensor color is obtained by a mono sensor, pulse suitable RGB color filters. Each pixel or color filter has a small lens placed on top, improving significantly light gathering at pixel side. On the right, it is showed that typical layout of a single CMOS sensor is showing. So this is taking in the sensor and it is the CMOS sensors and it is its details. So the typical DSC imaging pipeline. This is the sensors, CDS, GA, ADC, AWB, AE, AF, PIX, correction noise, then CFA interpreter. This is gamma, color distribution, color space. Then it is the application, image generation from here. This is image formatting. Then several links, NVMEM. These are, and this is the video encoder. The rapid growth of the digital still camera market segment is due to three factors mainly: the wider diffusion of personal computers, the increasing quality of the digital pictures, and the introduction of the to produce photorealistic images. DSC requires significant amount of processing. In addition, the standard image processing features like image capture and playback multimedia features such as video processing capture and audio playbacks are becoming popular in consumer DSCs. The high rate of innovation in the image processing technology used in DSC includes changing the product feature. The new features are now only related to functions implemented on board, but also to the availability of the infrastructure enabling the access to services such as online photo album, printing on demand, etc. The increased bandwidth and service capability of the 2G, 3G wireless communication is expected to contribute to trend. Services such as multimedia messaging and mobile internet will contribute to make image acquisition more pervasive, but at the same time will make easier to access to remote imaging services through a link between DSC and wire-linked mobile devices. The new JPEG 2000 standard is promising a lot for compressing efficiently and features to support at a cost of higher complexity with respect to JPEG. It provides a new image representation with a rich set of features, all supported with the same compression bitstream that can address a variety of existing and emerging compression applications. In practice, part 1 of the standard addresses some of the shortcomings of baseline JPEG by supporting the following set of features: improved compression efficiency, lossy to lossless compression, multiple resolution representation, embedded bitstreaming, processing, decoding, and SNR scalability, regional region of interest encoding, error resilience, random code stream access and processing, improved performance to multiple compression and decompression cycles, a more flexible file format. The complexity and the fact that in the range of visually lossless compression factor, the compression efficiency on JPEG 2000 versus JPEG is in the range of 10 to 15% higher. Both make JPEG 2000 attractive for its flexibility and features that must be exploited by a killer application. Synopsis: how a digital camera works. The word photography comes from the Greek words photo means light combined with the word graphics meaning drawing, which gives a sense that to draw with light. Simply we can say photography is the technique of record fixed images on a light sensitive surface. Light sensitive surface, this phrase differentiate analog and digital cameras. In analog cameras, the light sensitive surface is a film coated with chemical substances that are sensitive to the light. In contrast to digital camera, uses sensors to process images and sensors and stores it to digital files. Construction and mode of function of digital camera varies from their type to type, but basic principle of taking images is still the same. So basically these sensors and the inside of this digital camera are CMOS based, and that is in a chip like microcontroller or embedded system. So this is a fully controlled embedded system on chip. So this is all about today's lesson. So these are the references we have used. So thank you. We are ending the session.